Today we're going to be showing you how to replace a Potter PS40 low pressure air switch that we previously diagnosed as being bad. We're going to begin by opening our cabinet. Then first we're going to close our blocking valve. Apologize for the voiceover, but it turned out that the large chiller in the background was creating a lot of background noise. Next, we're going to close our main valve. This is to prevent anything from tripping or getting water into the system while we're working. Just in case, we're going to remove our solenoid valve. While we probably won't trip it, it's always a good procedure to make sure it's removed. So we're going to remove the nut, set it aside, and then we're going to take the solenoid off of its stud. Now we're going to open up our pressure drains, remembering first to turn off of our compressor. Now, this system has a fast fill, which is closed, and also a nitrogen bleed. However, we turned it off at this point and then realized we don't need to do that and opened it back up. The reason we closed the blocking valve was to keep the pressure in the system. This has a nitrogen corrosion prevention system that keeps corrosion from happening in the pipe. So with the pipe filled with nitrogen, we want to keep the nitrogen there above the blocking valve. So that's why it's closed, and we're only going to be draining the piping here. So we're going to open up our main drain here. Actually, that is our intermediate drain. So once the intermediate chamber is fully bled down, we've confirmed that on our gauges. Now we're going to open up our main drain. Make sure that this area of the system is totally bled off. We can confirm that by looking at our gauge, and it is down below 50 psi. Next, we're going to remove these wires. Two of them have already been capped off when the pressure switch was diagnosed as bad. So we're going to remove these two wires, grab some tape that we left, and we're going to tape these wires up so we don't accidentally short them against something. Wouldn't cause any major damage, but it's always a good thing to do. Just good standard procedures. I'm going to loosen up the fitting from the watertight flex. A little bit of a headache to get to. And then because this system is also rated for a 120 volt connection, we have a ground screw that we're going to remove. So we'll remove that ground screw, and later we'll put it back because it's always a good thing to have one, although not required on a low voltage system that this is connected to. So we get that lock nut off, take the flex and its wires out through the opening, and just so that it doesn't ground out against anything for now, create a trouble on the panel, we'll tape the other wires up as well. Now we're ready to remove our pressure switch. So we're going to grab it by its body with our channel locks. And again, everything is in a nice open area to get to inside of these TotalPaks. Very, very little room to work with, as you can see. So we'll go ahead and remove our old failed switch completely from the system. Always pause near the end just to make sure that there isn't any pressure. Even though our gauge says it's 0, we like to be careful. Here's our new Potter PS40. This is a -2 that has 2 contacts, although technically we don't need both of them in this application. Ethan wanted to open the box up because he said his knife was better. Thank you, Ethan. So now we take our new pressure switch. We need to remove the cover. For that, we're going to need our tamper resistant Allen inside of our multi-driver. Now, notice that this switch here, now that we have our Teflon tape, Ethan saved the day there. I left mine down in the truck. Fortunately, one of us came prepared to work and the other one left all his tools. Always use Teflon tape on a pressure switch. If you use dope, it'll get down inside of there, it'll damage the switch, bind it up. That's no good. Now remember, this switch, part of it's plastic, a little bit of it's aluminum, but you don't need to tighten it. We're not going to kill this switch. Now, of course, because I'm working in a tight location and videotaping, what's going to happen? Well, it's not going to want to start. And it's going to want to cross thread. And it's not going to want to go in. And there's going to be rust in the system. Sometimes you got to get your finger in there and clean it out a little bit. And now we're going to skip forward a little bit while I work on getting the trash cleaned out. Okay, you really didn't want to see 5 minutes of me fighting the thing that was trying to cross thread, so we skip forward a little bit. Go ahead and tighten it in. Again, remember not to go completely crazy. You are tightening plastic threads into galvanized steel, so we don't want to overdo this. It looks like I'm going a lot tighter than we actually are. It's just we're in a really tight location and I'm trying to feel how it is. And we're going to go one more round because I don't like leaks. So now we have it tightened. We have our opening lined up with where it was before. We're going to go ahead and reattach our cable back into the system. First getting the weatherproof connector into the back of the device. Snake the wires through nice and gentle. Take our lock nut, place it back onto the system. Tighten down our weatherproof connection. Again, this is just plastic against aluminum. We don't need to kill it. We just want to compress the rubber gasket just enough to make a seal. There we go. Now, all that's left is to go ahead and loosen up our terminals. We'll connect our wires back up where they were before. The negative going on the common, the positive going on the normally open. Technically it doesn't matter as this is just a Form C switch, whether you have the negative or the positive in which direction. But I like to do that for consistency. Now, we sometimes have to set the pressure switch. If you notice here on the old switch, there's a little wheel that spins. The top of the wheel where it lines up with the pressure mark is about the pressure that you have. This allows you to adjust it up and down for different systems based on what you're seeing. Normally they come from the factory relatively close, but we will be checking that. So we're going to get our meter. A little bit of light so we can see better what we're doing here. Now we're going to set our meter on resistance and we're going to check the continuity of the switch. It'll be normally open when the pressure is happy. Of course, right now it's shorted because the system was in supervisory alarm because there's no air. So we're going to go ahead and close our auxiliary drain, we're going to close our main drain, and we're going to go ahead and turn our compressor back on. So it's going to be a little noisy, except for the fact that it was already noisy from the background noise. We're going to bring the pressure up. What I'm doing there is just slightly bumping the switch to bring the compressor up in small increments, a few pounds at a time while watching the gauge, and it's about where it needs to be. So it's pretty close from the factory, but we're going to give it just a little bit of adjustment. So we'll reach down, open up the main drain to bleed some of the pressure off. Oh, and we see where it made up. So we're going to go ahead and bring it back up with the compressor and bleed it down a little bit. When you're dealing with this small of a section of piping, it jumps around pressure-wise very quickly. So you'll probably check it a couple of times to get it dialed in exactly where you want it. So we're really close. It's almost where we want it. If somebody was nice enough to write inside the door what the original factory settings were and the design pressures, so we're pretty close to those, within a few pounds tolerance, so that'll be okay. See which way we need to go with the pressure switch. All right. We're going to bleed it down again. See what we have now. So yes, I probably could have just put it in from the factory, used the pressure rating that was there. Would it have worked? Yes. Would it have given the customer the optimal conditions that they needed and made it so that it worked in the best of their abilities? No. It's always better to spend a couple of minutes, give it a little adjustment. It doesn't take much, typically a quarter, half turn, no more than a full turn in either direction is usually going to get you what you need. So we bleed it back down again, we pump it back up, bleed it back down, pump it back up. To some it may seem excessive, but I tend to be really picky about our work. We like to have it dead on and really make sure that we know that when we leave, the system is exactly where it needs to be and that it's going to give the customer early warning before the valve actually trips. So, all right, we've got it pretty well set up. Again, it was pretty close from the factory. It took maybe 3/4 of a turn and we were good to go. So now we're going to go ahead and put the other set of wires back on, and then we'll close the system up from there. Now, some of these wires were stranded, so we're giving them a little twist as we put them back in to clean them up. Tuck them up nice and tight so that when we put the cover on, it doesn't pinch them. Slide our cover back on, snug it up. Doesn't need to be tight, but enough again to hold the gasket so any spraying water doesn't get inside the switch and damage it. Compressor right now, we do have it on, as you can see here from the switch. We're only going to be doing this for now to set up the system so that we don't use up any of our nitrogen. So our drain system's closed there. Our main drain's closed, our blocking valve still closed. We have street pressure and nothing on our intermediate chamber. So we're going to slowly open up our main valve after we close the drain. Going to ease that in nicely so we don't jump the clapper out of position. We should still have street pressure there on our upper valve. Our lower valve is our intermediate chamber, which should remain at 0. If it does climb up to street pressure, though, that's fine. It's just the priming water bypass. Okay, no loud bang. We've set up properly. We'll go ahead and open our main valve all the way up, ensuring that the yellow flag is completely open so we have full flow in case of an actual fire event. Check all of our priming valves, our test valves, our drain valves, make sure they're all in their proper locations. Okay, everything's back normal. Last, we're going to open up our blocking valve so we can tie everything back into the system. Now, something that we don't normally do, but because we have the nitrogen fill anti-corrosion system, we want that to be able to fill the pipe up. We don't want the compressor to be pushing oxygen back into it, so we're actually going to turn the compressor off. And the few times that you ever do that, because we don't want the compressor to be running. It's filled up from the nitrogen system. Now we're going to replace the solenoid onto its actuator, snug its retaining nut back down in the position. We're going to apply a couple of tamper seals. We'll record the number later. This is to ensure that nothing is tampered with the system, nothing comes apart, and we have a record of it. So we put one around the solenoid, showing that it's been secured. One going around the main valve. And that's it. Thank you very much.
I just got to pick on all my sprinkler buddies out there. This is how you can tell I'm an alarm guy and not a sprinkler tester.